Hello everyone and welcome to our calculus notes for section 4.5b. Today we're talking about change of variable for definite integrals. So in this example, we are going to be evaluating these definite integrals, and they're going to involve composite functions that we've been working with over the last couple days. So what you'll notice here is we do have a composite function. So we got this inside part, and then we have an outside part right here. Okay, and so what we're going to do, because this is definite, is we're actually just going to erase this first, and let's just find the indefinite integral here. So when we did this, remember, we kind of let the inner part equal this, and then we found du, so we found the derivative of this, which is 2x dx. And then we did the thing where we could multiply and divide. So let's just do that for now. So we need to have 2x dx. I see x dx, so I'm going to multiply by 2 and then 1/2 right there. Okay, so what we're going to be left with here is 1/2. And since this is perfect now, we have something to the third power. So that something is going to go to the fourth power and then divide by 4. And we're going to keep the inside function the same there, so x squared plus 1. Okay. Now we're going to come back and think about our definite integral. So this is going to be from 0 to 1. All right, so I am going to go ahead and simplify this a little bit before I start plugging things in. So it's going to be x squared plus 1 to the 4th, and then the 2 times the 4 here will make 8 in the denominator. And we'll evaluate this from 0 to 1. So first off, we're just going to plug in the top number, the 1. So we get 1 squared plus 1. This will be to the 4th power over 8. And then minus, we're going to plug in the bottom number. So 0 squared plus 1 to the 4th power, and that's going to be over 8 as well. We'll do just a little bit of calculating and simplifying. And so this actually becomes, let's see, 2 to the 4th, so 16 over 8. And then minus 1 to the 4th, which is 1 over 8. And so all in all, we are left with 15 over 8. In this next example, I do want to show the actual U-substitution way. So in this case, again, notice we have this inner function and an outer function. Okay, so we are going to let u be that inner function, x cubed plus 1. Du is going to be the 3x squared dx. And what we're going to do in this case is actually just solve for dx. So divide by 3x squared. Okay. Now we do want to just kind of get rid of that for now. We don't want to think about it yet. And so we're just going to substitute here. So we have the integral x squared. All right. This is going to become u squared, and then instead of dx, which is right here, we're going to write du over 3x squared. Okay, so that's going to be du over 3x squared. Now what's going to happen here is hopefully the variable part, this x squared, okay, ends up canceling out. All right, so that's gone. And then if we were to rewrite this after canceling, we get definite integral of u squared over 3 du. Okay, now let's go ahead and perform the integration. So we're going to add 1 to the exponent and then divide by that new exponent. Okay, so like that 3 is that 3 right there. This 3 was actually that 3 right there. Okay. So we're going to get u cubed over 9. And now we are going to back substitute. So u was x cubed plus 1. So that u right there is going to become x cubed plus 1. Okay, so right there, we're going to back substitute. And so we have x cubed plus 1 cubed over 9. Now we're actually going to uncover these limits of integration again, okay, and we're going to apply them. So -1 to 2. Okay, so all the way through here, when you are doing the U-substitution, just really don't worry about those limits of integration until you get to your final indefinite integral, and then you can plug them in. All right, so we're going to plug in the 2 first. So 2 cubed plus 1 cubed over 9, and then minus negative 1 cubed plus 1 cubed over 9. All right, so that's what, 8. 8 plus 1 is 9. 9 cubed over 9. Oh, yeah, so that's just going to be 9 squared, so 81. And then here, negative 1 cubed is negative 1 plus 1 is 0. So we're actually just going to subtract 0 here. And so we get an answer of 81. All right, so that's where we can actually use U-substitution instead of the multiplying and dividing. Let's try a couple more examples here. All right, so the first thing we're going to do on this problem is rewrite it to get the radical out of the denominator. So this will be the definite integral from 1 to 5 of 3 times 2x minus 1 to the negative 1/2 power. Okay. So we're going to let u be that inner function again. So 2x minus 1. We're going to find du is going to be 2 dx. Solve for dx, so divide by 2, and that cancels. Now we can perform some substitutions. So this 2x minus 1 is going to become u right here. And then that dx is going to become the du over 2. All right, so we have 3 times u to the negative 1/2, and then du over 2. Now notice I dropped out the 1 and the 5 here because these are actually x values here and here. So as soon as I write this with a u, okay, I can no longer write x values here. I would have to write u values. So when you look at this, u is equal to 2x minus 1. So I would just take that x value and plug it in here, and that would change it. So this would be 2 times 5 minus 1. This is going to be 2 times 1 minus 1. Okay, so this is one way to do it, is to actually change those x values into u values. And it's kind of cool. Watch what happens here. So our definite integral is now going from, let's see, 2 times 1 minus 1. Well, that's still 1. And 2 times 5 minus 1 is now 9. Okay, if we combine the 3 and the 2 here, we have a 3/2. So I'm actually going to just put that outside. And then u to the negative 1/2, and then du. All right, let's keep on going here. So now we have 3/2, and let's take this integral. So this is going to add 1 to negative 1/2, so that'll be 1/2. And then you can divide by 1/2, but I would probably rather multiply by 2 over 1 here. All right, and since we changed the limits of integration into u values, I can keep the 1 and the 9 right here. All right, so we'll simplify. We get 3u to the 1/2 evaluated from 1 to 9. And we're just going to plug those 9 and the 1 in because, remember, those are u values. We found them right here. So we're going to have 3 times 9 to the 1/2 minus 3 times 1 to the 1/2 power. All right, half power, square root. So this is really 3 times 3 minus 3 times 1. So we really have 9 minus 3, and we get 6. All right, so this was using a total u substitution and even changing your limits of integration into u's. Let's go and do one more example here, and we can use the same method, okay? So first off, rewrite. Okay, look at that inner function. We're going to let that equal u and find du. From here, you want to solve for dx. So divide by 4x. Okay, that cancels there. Now we're going to do a little bit of substitution. Okay, so we're going to keep that x. This becomes u to the negative 1/2. And then du over 4x. And take a look at those limits of integration. It was 0 to 4, but now we're going to plug that in here and put them as u values. So this is going to be 2 times 4 squared plus 1 and 2 times 0 squared plus 1. And by plugging it in here, we don't have to back substitute for x at the end. All right, so let's keep going here. So 2 to the 0 squared plus 1, that's just 1. 4 squared is 16 times 2, 32, so this will go to the 33rd power here. Now, it looks like the x and the x cancel, so that's great, but we still have the divide by 4. I'm going to move that out here, 1/4. And then we have u to the negative 1/2, and then du. All right, so let's go ahead and find that antiderivative. So we're going to add 1 to negative 1/2. So that'll be positive 1/2. And then instead of dividing by the fraction, we're going to multiply by that reciprocal, 2 over 1. And then we evaluate this from 1 to 33. All right, so it looks like we get u to the 1/2, or the square root of u over 2, evaluated from 1 to 33. So we're going to substitute that top number in first, square root of 33 over 2. Substitute that bottom number and subtract, so square root of 1 over 2. And this really becomes your final answer. Minus, square root of 1 is 1, so minus 1/2. If you wanted to, you could combine the fractions and get something like that. All right, so that is finding definite integrals using change of variables.